So you say you have a question about assignment 4, eh?
Yes.
Just give me a moment to pull it up. I will be happy to answer it. That's practice 4, that's not assignment 4. Okay, what is your question?
Okay, so the question is from the second feature, delete all. The
Yeah.
instructions state, create a delete all button that when clicked will delete all behaviors from the table and reload the page with an empty table. So
Yes.
my question is, am I deleting the behaviors from the table, leaving all remaining data? Or am I removing all of the data from the table, for example, name and behavior, leaving an empty table? Do you want the behaviors just to be deleted, or do you want the whole thing to be deleted, leaving just the table? Because this can be interpreted in two ways.
Yes. Just give me one moment. I realize I have it over here. Duplicate. There we go. So, right here, this is ambiguous. Behavior is a field in the table, but the stated endpoint is that all table entries should be deleted afterwards. So, my interpretation, well, basically in ambiguous situations like this, if people do it one way, I give them the marks for it. If they do it the other way, I give them the marks for it if the question is ambiguous like this. However, if you want my sort of what is the most correct way of doing it, I would say the word behavior here probably means record. So it wants all records deleted from the table. Which is, you know, name, behavior, all the rest of the data, XFun. Awesome.
Perfect.
Any other questions about the assignment? While we're on the topic? No? Okie dokie. So, this week is also the test week. We had the test already, so on the modules, there's not really much to cover, and that which there is to cover, we have already, in a sense, covered. We can take a look at it quickly, but I thought it might be useful to it might be useful to set up some of the material that we're going to be covering next week, since we have an hour. So next week we will be talking about sessions. The next 2 weeks, basically, we are building up to being able to produce or understand at least how a login system works. You know, login systems are fairly important. So, There we go. Get out of here. Get out of here. So, essentially, the piece of technology which makes sessions work is the cookie. And cookies are kind of glossed over in next week's information. You know, one might even say frosted over. So I think that if we take some time today to explore the topic of what even a cookie is, we'll be better prepared for next week when we're using cookies to create sessions. Suitable plan of attack? I hope. But before we get to that, let's take a quick look at the form validation example that we have for this week. Again, I don't think there's anything here that we haven't already talked about. The purpose of this PHP script is to present a form to the end user, collect information from that form, and then apply certain constraints to it. So, if we load up XAMPP, because this is PHP, we will need XAMPP. htdocs. Let's make a new folder in here. My goodness, we're getting late into March, aren't we? Let's make sure that XAMPP is running. We don't really need the Apache server, we don't really need the SQL server for this one, so we'll just leave it alone. And then localhost 1080 /2024-03-15. There we go. Load up script.php. And you can see that we have username and password, just a simple little form. If my username is Dr. and my password is none of your busyness. There we go. Submit. Hello, Dr. with password none of your business. Username must be between 4 and 10 characters. Password must start with a digit. So this is just a way of running some simple checks against stuff that's been input by the user. Again, there's nothing here that we haven't already talked about, with the possible exception of these different filtering functions. So, in PHP, the function that you use to judge the length of a string is different from that which you use to judge the length of an array, for instance. Does anybody remember what we use to judge the length of an array in PHP? Count, correct. Not length. Most languages it's length or len or some variant on that. In PHP it is count, except if you're talking about strings, in which case you use string length. Incidentally, string length is a function that is being used from the C standard library. that many of PHP's string operations are just reskins of C functions. You also have C-type digit. C-type stands for character type. There's a whole bunch of these. C-type alnum gets you, is it alphanumeric? Alpha, is it alphabetic? Control characters, digits, graphing characters, lowercase, print, punctuation, space, upper, hexadecimal digits, etc., etc. There are lots and lots and lots and lots and lots of these, so any type of character that you want to check, there's a C-type for it.
So check for what?
So it's a function that returns a Boolean true or false value if the character which it receives as input is in the group of characters that is specified. So for example, C-type upper will return true if the passed character is an uppercase letter. Alnum, alphanumeric, means it's either an alphabet character, upper or lowercase, or a numeric digit, right? An Arabic digit. Yeah, so when you're checking to see if passwords contain, any of these special character groups that you want in passwords, this is how you would do it, is using C-type. In this particular instance, we are only using C-type to test to see if the first number in password is, or if the first character in password is a number. So, we can try a game. Our username must be between 4 and 10. Doctor. Our password must start with a number. 9 is fine. There you go. Success. And then our array output is gives us an indication of the username and password which we have entered. Any questions about this example?
What if you need a specific pattern in the password, for example? You won't be able to do it with this function.
What kind of specific pattern?
What if you need an uppercase, a lowercase, a special character, and a number?
Okay, let's do it. So, let's consider the documentation for C-type. Checks if all the characters in the provided string text are uppercase characters. So, in this case, what you're going to have, the C-type functions will only return true if all, you can apply them to either a single character or a string. If you apply them to a string, it will check that all of the characters in the string are uppercase, lowercase, etc. So, we can't use these directly. We can't just throw our password into one of the C-type functions and, this will tell us if there's one. It will only tell us if there are many. So, what we have to do is run a simple little loop and keep some flags. So, we want to check every character in the password. So let's set up a for loop. For I I is less than string length of password, I++, right? Now, we should have some Boolean variables to indicate whether the password has all of the different characters that we want. So, has upper, has lower, has number, and has special. We'll set each of these to false. You can probably see where I'm going with this, right? So, if password at I, and we want to apply one of our C types, C type upper, for example, then has upper equals true. If C type lower, then has lower is true. This is just a compact way of doing these if statements. Otherwise, it takes up the whole page, you know? We want a numeric digit. There we go. As number equal to true. And if C type, so I'm going to assume punctuation is special, but this is where we should take a look at the documentation to see what characters specifically C type punctuation will get us. Checks for any printable character which is not white space or an alphanumeric character. So that is more permissive than these things usually are, right? They usually exclude certain characters from being included in these, like parentheses and like greater than, less than signs, and it's usually just like the characters above your numeric keys from 1 to 8 on your keyboard, right? So for the time being, though, let's just go with this because if you wanted to restrict it further, you could absolutely, but for the purposes of this example, this works, right? So C type punctuation, password FI. Has special is true. Now, technically speaking, we don't have to recheck. Like, these are all exclusive categories, right? So we don't have to check if a character is both an upper and a lowercase in a digit, right? So you could very sneakily sneak some else's in here. And that makes it a bit more efficient because now you're not repeating redundant checks, right? But, it's still fine. So, I'm just going to comment this bit out. Now, we can write a neat little if statement at the end of all of this. If these Boolean variables are all true, then we have a good password. So, if has upper and has lower and has number and has special. Boy, don't you just love PHP and like all of the dollar signs? I know that's my favorite part about PHP. Echo password is good. Or perhaps, yeah, we'll just leave that like that. Else, we can choose here to just do a generic, password must contain one of blah, 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 and blah. But we actually have more information than that, right? Just because of the way we did this. But first of all, we should increase errors, as that's what this program is using to track whether overall the operation was a success or a failure. And then we can say, if not has upper, echo just put some breaks in here. Password must contain an uppercase character. Lower must contain a lowercase character. Number must contain a numeric character, and special must contain one of something like that. Technically, this is more, this is less restrictive than that, but the end user doesn't need to know that. Save. Now if we, okay. I just realized that this isn't the version in XAMPP that I'm working on here. This is the version. Open, paste, there we go. Save, get out of here, there we go. Refresh, cancel, refresh, continue, there we go. So if our username is doctor and our password is password, submit. Must contain, and you can see all of the things that we get. Doctor, and if we choose a better password, like password 123 exclamation point, password is good, operation is successful. Make sense? So really it's just a matter of using our existing programming skills to produce the Boolean results that we want. Any other questions about this example?
Instead of going through all of that process, could you use a function like a pattern matching?
Pattern matching.
So that's kind of what it is.
and see, does PHP does what the 2 like I know it does it on like data structures. Pattern matching means something very specific. Are you talking about regular expressions? Yeah. So yeah, I mean, if you want to use regular expressions, you can use regular expressions as well. Regular expressions are extremely powerful, beyond the scope of this course.
I thought it would be easier to look for a pattern rather than searching for each individual item.
Well, I mean,
it's logical both ways, but
yeah.
I just thought that it would be easier.
So there's this great website called regex101. Have you seen this before? So regex101 is a website which allows you to test regular expressions. So, you know, the question of using regular expressions comes down to, okay, sure, it's quote-unquote pattern matching, but basically, how, like, there's, it's like,
What do you mean by regular expression, Dr. Moore?
yeah, see, that's the issue, right?
Like what
So-
makes it regular from non-regular?
So a regular expression is a different form of computation called a finite state automata. I can run it through, I can give you the old note version, which is probably going to be just enough for you to say, it bollocks to this. So a regular expression, in a regular expression, basically it's a type of finite state machine. So let's imagine you have the character S, right? And the character, or let's do the character H, the character A, and the character space. And you want to match patterns. Basically, if somebody writes ha, 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 or ha, 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 right? Basically, you want to say something like that, right? You want to go from H to A to space and then optionally come back again to the front. As a regular expression, you write this HA space star, which means zero, or plus. I think plus is one or more iterations of this. You also have wildcard characters, so if you replace this with, I think it's period, HA, or H, oh man, get my fingers all marked up.
The periods are joining together.
No, it's a one character wildcard character. So that would match he, ha, who, z, all of those strings would match this because this is a wildcard character, right?
So something like that's only going to work if you specify the exact pattern that you're looking for, essentially.
Like, kinda. You can do things like, for example, upper, I think, how does it go again? Upper, there we go. I forgot how to do it. Let's see here. So I'll do that example, right? So if you have strings like ha, 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 he, ho, ho, as, right? A, huzzah, right? If your regular expression is ha, you can see it gives you a match everywhere in that string where the word ha occurs, or those characters. If I put the space in, I now have to have all instances of ha followed by a space. If I put a plus after, I had plus, I think. Yes. Then I've got a couple of captures, but you notice this one is not captured because I don't have the space afterwards. Once I put the space in, suddenly I've got a whole capture there. But it's like recursively capturing these three, that two, and then that one as well. If I replace the A with a dot, you can see it expands the capture to include the next line, but not that second line, right? So this is what a regular expression looks and feels like. I've worked with regular expressions a reasonable amount. They're an extremely useful way to search text. But
Or filter inputs that the user's entering.
see, the problem is, it would not be that straightforward. Well, like you'd still have to run several regular expressions over your text, I think. Like you would have to run a separate one for like, detect me one character inside of this string if it's uppercase. Is it 2 upper? Probably U. There are a bunch of tags. Leave a regular expression uppercase. Oh, I guess you can do it that way. So you can say, in a regular expression, you can say, give me something from capital A to capital Z, right? Or lowercase a to lowercase z, right?
Which will be everything, okay. So you can put restrictions on it.
So if I were to
based on what you're accepting.
grab lorem ipsum, for example. Where is lorem ipsum? This is just about lorem ipsum. There we go, right. Right? So right now, all I'm matching is any uppercase or lowercase letter, right? If I put a space, now I have all of those letters which occur, like all those combinations which have a space after them, right? If I say any number of upper or lowercase letters and then a space, you can see I've grabbed everything except things ending in punctuation, right? So it's just, like you could regex over a password to find out if there's an uppercase digit in it. But, it's like,
In a password scenario, Dr. Moore, you're probably not looking really for a pattern.
No.
You're,
no, you're only really looking for the presence of each of these characters, right? So basically, you wanted to light a birthday candle, and you brought out like a World War II era flamethrower. That's where we are with this.
okay.
Does that make sense?
I just thought it may be easier to combine everything into one.
I don't know if it would be possible to combine everything into one, because like really,
But
you're checking for separate things, you know?
it probably doesn't make sense with a password.
Well, like,
For
I
example,
don't know how to get a match, I don't know how to get a negative match, right? I don't know how to say in a regular expression, don't match if this isn't, like, don't match if you're missing this.
would it be the explanation or exclamation symbol prior to that statement?
Well, you could also, so square braces do ranges, right? You could say, like your punctuation marks as well, right? Or you could say, you know, there's like optional punctuation, that includes the punctuation, right? But like,
I didn't mean to throw you off track, Doctor. I just.
yeah, regular expressions are a lot more complicated than they seem. It's like, if I have a structure where all I'm doing is jumping from one letter to another, it's like, you know, there might be a way to do it, but,
The reason why I'm asking about this, Dr. Moore, specifically is because I use this function in one of the assignments to get, where am I? To get the health card number for that matching.
Oh, that's a good application, right?
So I just thought, if you're going through all these steps, like you're looking for an uppercase, a lowercase, a number, it's kind of like a pattern if you put in a range of what's acceptable. It may actually be more complicated in a password scenario.
Yeah, it's like, the problem is that like, you can go through a health card number or a phone number or something like that, character by character, and each character has to be of a specific type. The problem with the password is basically that it requires look back, which,
So you're kind of going back and forth with that.
yeah, like it's easy enough to say, you know, 0 to 9, you know,
For a range.
for a range, and say, give me 3 of those, a dash character, 3 more, a dash character, right? And then, you know, 1, 2, 3, 3 dash, 2, 3, 4 dash, 4, 5, 6 matches. Whereas if you get one of the number of characters wrong, it doesn't match. That kind of stuff, fantastic for regular expressions, I agree. The problem, and maybe it's just like my conceptual problem, but like, the issue is, if you have let's pick one character, right? Or let's make it so that this character here might be a number, a lowercase, an uppercase, and that's good enough, right? Somehow I messed this up. Got an extra brace. There we go. So if this is an A, right, it works. If it's a capital A, it works. If it's a number, it works. But like, if you use this 2 more times, right, I get a match if there's a character, right? I get a match if it's all uppercase characters. I get a match if it's all lowercase characters. There's really no way to say I need one of these and one of those and one of those, or at least one of these, at least one of these, and at least one of those. It's not really how it computes things. Again, maybe my understanding of regular expressions is just not good enough to be able to perform that operation.
I think that makes sense, Dr. Work.
But yeah, so, okay. That's a good question though. Regular, like, it's good that you're brushing up against regular expressions because they are highly, highly useful. I use them in bash scripts all the time to like pull stuff out of files in the file system and stuff. But anyway, I've got 8 minutes left to tell you what a cookie is. So here's what a cookie is, all right? Well, let me start my explanation of cookies by asking you what you think a cookie is. What do you think a cookie is? Because that's a term that we know, right? From our use of browsers and computers.
Used for tracking.
Cookies are used for tracking, yeah. You're supposed to clear them periodically as a safety measure, right? So, what is a cookie? A cookie is a tiny, tiny little piece of data which is stored on the browser, on the client system by the server. So, let's imagine we have our client, we have our server, the client sends a request to the server. The server sends a response back to the client. That response includes a cookie. Right? So the cookie gets saved to the client computer's hard drive. Or maybe not hard drive, it gets saved to memory anyway. Make sense? Then, time passes. The client initiates another request from the server. The request will always include the cookie that was sent. Any cookies that apply to this server are sent automatically in any request packet. This is an important thing to understand about how cookies are communicated, right? So, basically, whenever the client is putting a request together, it looks through all of the cookies that it has for everything. It picks out all of those cookies which apply to this domain, right? The server is a domain, right? So, for example, this server might be CS Unix, for example, .mohawk, etc. The client looks up all of the cookies it has for csunix.mohawkcollege.ca, sends those automatically with the request packet. So it allows the server to store some information on the client, but not reliably, right? So one of the things that you should never, ever, 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 ever do is trust the client, right? Cookies are, for one thing, clients delete them, right? So a server can issue a cookie, right? The cookie can be deleted, and then the server has literally no idea that there was ever a cookie there in the first place, right? You've probably heard this from your networking class, right? HTTP is a stateless protocol. Have they said that to you guys? So what that means is each incoming request packet, as far as the server knows, that could be from literally any computer anywhere in the world. Who the heck knows, right? So this is sort of the way that the internet was originally designed. The internet was originally designed for anonymity. However, basically as time went on, they built things to get around the implicit anonymity of the internet in order to be able to do, what are theoretically useful things, such as internet advertising. So, you've heard of the tracking cookie. What you often use cookies for is to identify a client, right? So if rather than sending just some regular string, we issue an ID number, right? The client stores its own ID number and sends it back to the server, thus identifying the client, right? This is, there's lots of different ways this is used. Next week we're going to study sessions. Basically, this is how a login session is maintained, despite the fact that each request could be coming from anywhere and anyone. You issue an identification number to a client when that client successfully logs in, and then that identification number is sent back every time that client requests something else. So the server is like, yeah, okay, you're this person who is currently logged in. Of course, this is, these things can be both modified and stolen, right? So part of the reason that you want to delete your cookies all the time is that if somebody manages to get some malicious JavaScript executed on your machine, if you have any cookies for, particular domains like your bank, which are, current valid session cookies, those can be stolen by a bad actor, and then they have your login. They don't know your login password and username, but they have your login session, which is usually enough to do more than enough damage. Particularly if your bank or wherever doesn't require you to re-enter a password to change your password, right? If you have the session but you don't know the password, you can't change the password if you're being asked for it. But if the website does not require you to re-enter your password, to change the password, losing the session cookie means that you may lose your whole account. You'll be locked out of your own account. And then, it's customer service time and hope that all of your money or whatever is still there, which it probably won't be. Does that make sense? We'll talk more about this next week, obviously, but I'll also talk a little bit about how the introduction of cookies to the internet was basically the beginning of the end of the free internet, as it allowed advertising on the internet to exist and work, which is the source of much of the evil on the internet, in the humble opinion of this poor, humble professor. So, thank you and good night.